Alright guys, in this example we are asked to compute the area of a parallelogram when we're given only the side lengths of two adjacent sides and the angle between those two sides. So I could have drawn this so that we know the angle up here, but I chose to make this angle down here. Either one is fine and the argument will be the same. The argument that we make here will be the same. So we need to, and it says to use trigonometry to do this, right? So I've started here by drawing what I claim is a parallelogram. It may or may not be, but we're going to assume that it is. And we want to try to compute the area of this thing. And we know that the area of a parallelogram is the base times the height. So in this picture, if we look at this the way it is, right, the base is going to be A, and the height is going to be this distance right here. So this length here we'll call H, and that'll be the height. And what we need to do if we're going to compute the area is we need to find a formula for H, right? So we need to find a formula for H. And notice that this height, H, is the same as this altitude, right? Or, maybe even better, say this altitude right here. And we want to try to find the value for this H right here. And notice that this is made a little right triangle. So it's made a right triangle. The angle down here is the right angle, 90-degree angle. And the angle opposite of this H is theta. The hypotenuse of this triangle is length B. And A doesn't play any role in the triangle because A is the entire length of this base down here. It has nothing to do with the base just to here, right? So we don't know. We don't know what this value is. But we can find H just by using trigonometry because we have the opposite. That's what we want, right? So remember that the sine function, right? So sine of our angle is equal to the opposite length divided by the length of the hypotenuse. And we know both of those. So in this case, the sine of theta is going to be equal to H over B. Okay? H is the opposite side, B is the hypotenuse. What we can do now, remember we know B, we're assuming that B is a number that we're given here. What we can do now then is solve for H by multiplying across by B, right? So this then tells us that H is equal to B times the sine of theta. Okay? Now, that's our height. We know our height, right? So at this point we can write down the area of this parallelogram without much trouble at all because we know that the area of our parallelogram is base times height. Now height of course is the altitude height. It's not the length of this side length, right? So that's why we had to compute H using trigonometry. But now that we know this, we know that our area is equal to the base, which in this picture is A, times the height H, which is given by this formula, right? So I'll write it in two steps, but it's A times H, or in this case it's A times B times the sine of the angle that they make. So the sine of the angle between them. And this right here is a formula for computing the area of a parallelogram. So let's do an example with some numbers. By the way, this should look familiar because remember we have a formula for the area of a triangle which is very similar to this. You can compute the area of a triangle, let's say this triangle, right? The one, so I'll shade in all the sides. This triangle's area, we know from our study in trigonometry, one formula for the area of this is 1/2 A times B times the sine of the angle that's in between them, right? Look at this formula, look at this formula. They're so similar, right? This one is just twice that, and why is that? Well, look over here. There's another copy of that triangle here, right? So this parallelogram is built out of two copies of congruent triangles, each of which has this same formula for the area. Okay, let's do a quick example with some numbers. Let's say that, look at this parallelogram. This one's even worse than the last one. Doesn't matter, right? So let's say this side length is 12, this side length is 8, and let's say that the angle in between them, this looks like about 60 degrees. What do you think? Yeah, perfect, right? It's not even built out of straight lines, but that's okay. And according to our formula here, the area, write this in black, the area is side length 1 times side length 2 times the sine of the angle between them. So A times B times the sine of theta. So for us that's going to be 12 times 8 times the sine of 60 degrees. 60 degrees is a special angle. So the sine of 60 degrees is actually square root of 3 over 2. That's one that you should know. So we can write it down exactly. This is then 12 times 8 times the square root of 3 over 2. And you know, when I'm working without a calculator here, you guys have a calculator, you can just type this in to get a decimal approximation. But if you want to leave it as exact, you do some tricks to kind of reduce the amount of work you have to do. And so now this is 4 times 8 times root 3, and when we write this out, the area of this parallelogram is going to be 48 times root 3. I'm going to leave it exact, just like that. If you want to get a decimal approximation, you can just plug that into GeoGebra and see what comes out. But the main thing you should take from this is that here's a trig formula for the area of a parallelogram. It only works for parallelogram, okay? It has to be a parallelogram. But the area of a parallelogram, if you know two adjacent side lengths and the angle between them, there you go. You can just use this formula.